In this video, we're going to continue with some of our log basics. We're going to be continuing with evaluating first. So remember, just to refresh, you are setting your expression equal to a variable. I'm choosing x. Then switch to exponential form. So 3 to the x is equal to 1 over 81. And then use whatever solving techniques you need to use on the equation. So I'm going to change 81 to 81 to the -1, because one side has a fraction, the other does not. Get them to be the same bases. Again, if you need to do a factor tree off to the side, do that. This will become 3 to the x equals 3 to the -4. We end up getting x is equal to -4. Remember, you want to rewrite your answer as log base 3 of 1 over 81 is equal to -4. You chose x as your variable. We weren't actually solving for x. The next two, since we have buttons in the calculator, you can switch to exponential form, but you could also type them in the calculator. So I'm just going to bring you over there real quick. Slide the calculator into the viewing window a little bit. Log is right down on the side, right next to 7. So I'll hit log 100. We already talked about there's 2 zeros there, so we should already kind of know that the answer is going to come out to be 2. And then for ln is right underneath log or next to the 4. So I'll pick ln or natural log. 4, notice in the calculator on the button it's a capital, and then when it shows up in the calculator it's lowercase. So we had talked about that earlier, meaning the same thing. And this one will round to 1.39. You're only going to get approximate when you have E examples and the ln's for those. And then the last one is a little weird. Once I show it to you, I'm going to show you what to expect for this in the future. We'll set this equal to x. Here, we actually are going to switch to log form, which is a little weird because the exponent is a logarithm too. So the base is 6. We're going to make this log base 6 of x. And we're moving this whole thing, this is our exponent here, so we're going to move that entire thing to the other side. It ends up happening that we get log base 6 on both sides, so same way that we could get rid of the bases before and set the exponents equal, we can set the inside of the logarithms equal to get x is 11. What I want you to notice in this question, when the bases are the same, your answer to this is the standout number, or the one that doesn't match the other two. So you actually could probably skip this middle part right here and go right to this final answer. Notice I highlighted in red. The standout number is 11. The base 6 is the same for the exponent and the logarithm that's up in the exponent. So the other number is going to be your answer for that. All right, and then we're switching over to equations, although our techniques are kind of going to be the same. If you are solving a log equation, you might be switching formats, or you might be setting the insides equal. It depends on the question that you're getting. So for the first two, I'm going to do the first step for each of them at the same time. We're doing 3, whoops, let's go back to black here. So the 5x is equal to 81. First two, we can switch to log form. This one's going to be x to the 4th is equal to 16. And then for solving, same techniques we used. Set the base is the same, set the exponents equal, and finish solving. Always a good idea also to check. And then here I could do it one of two ways. I could make 16 into 2 to the 4th. Notice that the exponents are the same and set the base is equal, which is a little different. Or we could go back and solve this the way we did earlier on. You can take the 4th root of both sides. That will also give you x is equal to 2. So that one didn't end up with an exponential equation. Some of them will, some of them won't. All right, the next two, you have to be careful with your bases. When you switch to exponential form, anytime you have something more than just one number in there, just like we did prior, use parentheses around things, because that's going to become important for the solving process here. And then you can kind of follow the same technique either way. You can make this into x minus 3 squared is equal to 7 squared. Technically, when you take the square, or if you took the square root, you would get plus or minus. But you can only get a positive base. You never have negative bases. So we're really only going to focus on the positive anyway. And then for the next one, I can do what I did on the other page. I could distribute the 5 in. I could actually make 32 into 2 to the 5th so that the insides can be set equal to each other since the exponents are the same. And I get x is equal to 1. You could also take instead the 5th root of both sides, which would skip you down to that step as well. Then we have some varying things in our next couple examples. In fact, I feel like probably 17 and 18 are kind of similar even though they look different. This one is like log base 5 of x squared minus 12, log base 5 of x. So if this had just said 5 to the x squared minus 12 and 5 to the x, you would set the exponents equal. You can also set the insides of the logarithms to be equal to each other. And then this is quadratic, so we would get it into the quadratic format to factor and solve. This would factor into x minus 4 times x plus 3. And we get x is equal to 4, or x is equal to negative 3. 4 is actually the only good answer. We do have to get into graphing to see and understand a little bit more, but if I plugged in the negative 3 onto the right side, this is no good. This must be greater than or equal to 0. So if you do check these in your calculator, it will give you an error message and tell you that same information. So I didn't need to do any switching formats on that. I just needed to set the inside equal. Whereas 18, I need to switch formats. I need to make this 3 to the 13 is equal to 3 to the 2x minus 5. Once I switch formats, the bases are the same. So I can go right into setting the exponents equal and finish solving. So although they're different, they have some similarities there where you're not actually doing any other simplifying work beyond that. 19, you remember ln is the same as log base e. So before we even start solving here, we want to rewrite it that way. So we can switch to exponential form. So e to the third is equal to x plus 5. This one, I'm going to get an exact and an approximate answer. So I'll subtract 5. X is equal to e cubed minus 5. And if I want an approximate, I can type that in my calculator. And it comes out to about 15.09. So again, special case because you have to change it into log base e. And our last one, because we're going to be doing this when we get into graphing, we want to solve for the log first before we switch our formats. So we'll subtract 5, negative log base 2 of x minus 1 is equal to negative 5. We're actually going to divide out that negative 1 because that's also something we want to get rid of if it's a number in front or even just a negative sign. So really this is like a negative 1 in front of the logarithm that we're dividing out. Once the logarithm's completely by itself, that's when you are able to switch to exponential form if need be, which we do need to in this case. and finish solving. So I just star that one because this is going to be an important technique, especially when we're solving for things like intercepts when it comes time for graphing. And also for application problems because those formulas will be a little more involved. All right, so that wraps up the basics of logarithms and solving equations where we're switching back and forth into our different formats.